Okay, so in the last class we were talking about loops, while arrays and loops in Java. So just to quickly remind you, the problem we were looking at in the last class was finding the location of the maximum element, in this case a Python list, but we want to do a Java array. Right, so we want its location, so we want to return its index. We want the function to return its index. In Python, one way to write this function, is to start by assuming the first element in the list is the largest element. Right? So we know that the index that we want to return is 0, at least to begin with. We assume it's 0. And then you loop over every element in the list. This time you use the index of the element to access the element. Right? And so if you want a counting style loop in Python, you have to use Python's range class. Right? So range in Python is an object that knows how to count from some starting value to some stopping value. By default in increments of 1, but you can use other increments instead. Right? So you make a range object that starts counting at 0, goes up to, but not including the length of the list. Right? And then inside the loop body, you simply look at the element at index ti. Right? If it's greater than the current element, you know you have a new largest element. So you remember what it is and where it is. When you loop over all the elements, you're done. Okay, so the equivalent loop in Java looks as follows. You want a counting style loop. So this was the only kind of loop we had in Java until version 5 of the language. Right? It wasn't until in version 5 they added the second for each loop. And I'm going to go back and look at that version in a moment. The code is almost the same. The thing that changes is the for loop itself. And so the way you write a counting style for loop in Java is very different than you write a for each loop in Java. In particular, the counting style loop has a very particular structure. And so we're going to have a loop variable I declared here inside round brackets. Right? And then I is usable inside the body of the for loop. After the for loop, I is not usable. So the scope of I is limited to the loop of the body. And so what we really want to look at is what does all of this mean in Java? Right? And so a counting style for loop in Java or a regular for loop in Java, most people just call it a for loop in Java. If you are talking about a for each loop in Java, then people call it a for each loop. So it's a little bit different than in Python. So the regular for loop in Java has 3 parts. There's an initialization expression. So that basically declares the loop variable and gives it a value. The second part is what's called the termination condition. So this determines, it's called termination condition. So it looks like it determines when the loop ends. Really it says when does the loop run. So if this condition is true, the loop will run. And if the condition is false, the loop will stop. Right? And you'll go down to the after the loop. And then finally you have the update expression. So this is what happens after the loop body runs once. Right? Every time it runs, every time the loop body runs, the update expression runs after the loop body finishes running. Right? So for every iteration of the loop, the update expression runs at the end of the iteration. Now, the interesting thing about the Java for loop is that all 3 parts are optional. The semicolons are not. So even if you have none of the 3 parts in the loop, the semicolons are still required. Okay, so what does the initialization expression do? So it's the first part of the loop, right? Basically that declares any of your loop variables, and then it sets the value of the loop variable. Right? So this is the normal way that you would write a counting style loop, where you're having where you're using an index variable I. The second part is the termination condition. And so before the loop body runs, right? So right here, right? The loop checks this condition here. Right? If this condition is true, then the loop body will run. If the condition is false, then the loop exits and you end up down here, right? So the loop stops running and you end up after the for loop, right? So every time before the loop runs, right, that condition gets checked. finally, the update expression is the thing that runs immediately after the loop body runs each time. So if the loop body runs here, then right here, I guess, is where that update expression runs. Right, so here I'm writing I++, and so this increments I by 1 at the end of every time the loop runs. Right? So I++ has the same effect in this case as writing I equals I plus 1. Right? Now you have to be careful about translating I++ to I equals I plus 1. It turns out they don't exactly mean the same thing. There is a subtle difference, but for the time being, it's fine, right? I++ means increment the value of I by 1, right? You could write it out manually as I equals I plus 1, that's fine. Right? Another way to write it in Java is to write I plus equals 1. Right, and so this also takes the value of I and adds 1 to it and reassigns it back to I. So that's what this plus equals means, right? So take I, add whatever this is back to I. Right? And so there's 3 different ways you can write this. They all have very subtly different meanings. Most of the time, it doesn't matter which one you choose. There's actually a 4th one, I forgot, sorry. Another way you can write it is plus plus I. Which looks very similar to the I++ that's here. Again, the meaning of all of these operators, it's there's a slight differences between all of them. For the time being, it's not important which one you use, right? They will all do the same thing. Right? Okay, so is sorted. This is the max index, right? So there's that explains how that loop is working there, right? And so there's don't forget that in the previous lecture I showed you what a for each loop looks like, and so to remind you, I'm just going to look at the assignment. So in the assignment, okay, you were given some classes and you were given some Python files, right? So we have a Python file somewhere. Where'd it go? Here we go. Okay, so here is rule 184.py. So this is one of the 2 Python modules that you're asked to translate into Java. Right? So the first function inside of the Python file is a function that simply prints out a list of values. It translates the values in the list is a bunch of true-false values. Right? It simply translates the trues to C's, and it translates the falses to I's, and it prints everything out on the same line. So it doesn't go to the next line every time when you put something. To do that in Python, you need to specify what the end character of the string is every time print prints something out. Right? So if you didn't know how to do this, this is how you do it in Python. Right? You specify that the end character is the blank, is not the end string. Sorry, the last thing printed out is specified by n. If you don't say that in Python, then the last thing that gets printed out is the new line string. Right? And so here you've got a regular Python loop. Right? And so this is suggesting to you that you should try to translate this to a Java for each loop. Right? That's a Python for each loop. Translate it to a Java for each loop. And so it turns out this is pretty straightforward to do. Right? So we're going to insert something that looks like print cells. There it is there, so I already put that in for you. Right? So you need to understand how do you translate that function into a Python method. Sorry, how do you translate that function into a Java method? Sorry, into a Java method. Right? And now you want to write a Java for each loop. So for, right? So remember how Java for each loop looks like? It's always for and then your loop variable, right? So when you specify your loop variable, you have to specify its type, right? Let's go back to the Python file. So the Python file calls the variable boo, so I might as well call it boo here too. Right? And then instead of in, Java uses the colon, right? So for each Boolean value boo in, the name of the array, right? So there's your for each loop. Don't forget your braces, because Java uses braces to define blocks, right? And now there's an if statement. Oops, sorry, wrong one. Here, right? So if boo is true, print out the C, otherwise print out a hyphen. Right? So if round brackets, because it's Java, right? If boo, right? If you wanted to, you can write equals true, right? But again, you don't have to do that because boo is a Boolean value. It's either true or false. So you don't actually have to check whether it's equal to true or equal to false. You can just write if boo. Right? I'm supposed to print out a capital C. So in Java, that's system.out. Now, to print out something but not go to the next line, remember that's just print. It's not print ln, right? The ln goes to the next line every time. I want to print out a C. So you can either use a string or a character here. It doesn't matter. I'm going to use a character, right? And that's it. So the Java version of print never goes to the next line. You never specify what the end character is in Java, right? Else system.out.print the hyphen, right? And there's your for each loop in Java, right? Okay, so the next function in the list is fill. And so fill uses, has two loops in it. They both use range, right? And so in this case here, you're going to want to use a counting style Java loop, right? It's also got this raise, so it also raises some errors. So I have to show you how to throw an exception, which I'm going to do shortly. And so we'll see how to, why don't we just do it now? So let's just translate this thing now. We got a round. We've got a bunch of things here that we haven't really looked at exactly in the course. The assignment tells you how to do everything, but I'll show you how to do it now. Okay, so fill basically fills in the array with some number of true and false values. Right? It tries to stick all of the true values in the front of the list, and then the remaining elements are all set to false. Right? How many elements get set to true? Well, it uses this percent density parameter. Right? So that's just the fraction of values that should be true. Right? So if percent density is 0.5, half the values should be true. Right? Now, it's a number of values, so it's an integer number of values, so that's why you have to round. You're going to multiply the density by the length of the array, and then you have to round the result because it's an integer number of values. Right? So to do all of this in Java, we would do the following, but it's going to be a little bit tricky because I only have one monitor here. Okay, so I need a method called fill. So public static, it returns nothing, so void. Right? Its name is called fill. It takes in an array of Boolean, so array of Boolean, and it takes in a density. Now remember, the density is a floating point value, so in Java, you use double. What's it called over here? Where is? It's called percent density. So I guess I should call it percent density here. That, right? Also remember that when you're naming your variables in Java, right, you want to use lower camel case, right? You want to avoid using the underscore. So in the Python code, it's percent underscore density. When you translate it to Java, make sure you translate it to percent capital D density. Okay, so we've got some error checking in the Python code, right? So if that percent density is supposed to be a percentage, it should be between 0 and 1, which is what these two if statements are checking for. Right? So if the density is less than 0, that's an error. This function can't actually do what you want it to do, right? And so this function raises a value error, right? And complains the user passed in a density less than 0, right? If it's greater than 1, it also complains. Right? So again, it can't actually give you an array that has 150% of its elements equal to true, right? That doesn't make any sense. So it complains and raises an error. Right? And so the way you do this in Java is, well, you write the if statement. So if percent density is less than 0. Right? Now here, remember percent density is a double, so you want to compare it to 0.0. Turns out if you compare it to plain old 0, which is an int, this works fine. Right? So you can compare ints and doubles in Java without any issues. Right? All that Java does here, right, it says, well, percent density is a double, right? And you're asking Java to compare that to an int. And so the rule in Java is it takes the int and converts it to a double. So even if you write 0 here, under the hood, the compiler or Java is going to convert this to 0.0 for you anyway. So this is also fine and will work in this case. Right? So if it's less than 0, you want to raise, well, in the Java code, the Python code raises an error. In Java, you throw an exception. So instead of the word raise, you use the word throw, right? Instead of value error, the assignment tells you to throw an illegal argument exception. And so you need to insert the keyword new here. And I'll explain exactly what new does probably in a week or so, right? So you want to throw a new illegal argument exception here, right? And then you want to also provide the message that the percent density is less than 0. Right? So if someone calls this method and passes in a percent density that's negative, what the throw does is it stops the code immediately at this point, right? It produces, it manufactures what's called an illegal argument exception object, right? That object, inside of it, has a string that's equal to that, right? Your program stops running. Whoever called the method now gets this illegal argument exception object. Right? It's the exact same thing that happens in Python. So when you raise a value error in Python, whoever called the function ends up receiving the value error object that contains information about the error. Right? If they don't do anything about it, whoever called that function or whoever called that method now gets the exception object, and so on and so on and so on. Eventually you get back to your main method. Your main method's probably not doing anything with the exception object, so then the program stops and you get the error message in your console. Right? So now that we know how to do that, it's easy to check the second case. Right? So if it's greater than 1, right, you can just change the condition, change the error message. Right? That's easy. Okay, next step is I need to calculate how many true values should be in the array. Right? That's just the percent density times the length of the array. I'm just going to go back and check what the variable name is that I used. N true. Okay, so n true. Okay, so I know it's equal to the percent density times the length of the array. So remember, how do you get the length of an array in Java? It's just arr.length, like that. Okay, so if I just write that, you'll see if you're, my Eclipse is complaining, right? It says there's an error here, right? If you can read the error, it says there's a type mismatch, cannot convert from double to int. Okay, so what's going on here? So that's a double value. You're multiplying that by an int value. So the rule in Java is it takes the int value, converts it to a double value, and multiplies it using all double arithmetic. Right? And so that produces a double value. Right? Java will not let you store a double value in an int variable. Right? If you want to store a double value in something, you have to store it in a double variable. So what you have to do here is you have to round the value and convert it to an int. Right? So the way you round something in Java is you use this class called math. It has a method called round, which does exactly what you think it does. Like that. Right? So I need to round that value. Right? And so you look at this and you say, well, sure, but it's still complaining there's an error. Right? And so it still says now there's a type mismatch. You can't convert from long to int. right? So the reason you can't, the reason it's telling you this is because if you actually go and look up what math.round does, right, it tells you that if you pass in a double value, it returns a long value, right? And so you now have the situation where all of this is a long integer value. Similar to how you can't store a double in int, you cannot store a long value in an int either, right? You have to tell Java, yes, I know this is a long value, but I want you to treat it as though it were an int value instead. So the round brackets in front with the int inside is a cast, right? So it takes whatever type this is, so in this case a long, and attempts to convert it to an int, right? And it turns out this is one of the conversions you can do, so this is fine, right? Don't try to, well, in this course, don't try to cast reference types. It's not going to do, it probably won't do what you want it to do. So if you're in the need of casting something and you're using the primitive types, it might be the case that you need the cast, right? Here you do need the cast, right? Avoid casting reference types in this course. We never actually do it in this course. All right, so there's your number of true values. And now we need to fill in the array. So going back to Python. So I'm just going to copy these over because I want to stop flipping back and forth. Okay, so I got two loops that use range, so I'm going to use the counting style Java loop instead. Right? So my first loop has a loop variable I, so I'm going to use int I. Right? The range starts at 0, right? So you start I at 0, semicolon. Right? The range stops at n true minus 1. Right? So I want the loop to run as long as n true, as long as I is less than n true. Right? So I want the loop to run as long as I is less than n true. Right? Each time through the loop, I want to increase the value of I by 1 because that's what range does. So I++. Right? Array I equals true. Well, that turns out to be the exact same code, except instead of capital T, you use lowercase t. Right? Second loop. So there's another I here, right? Another loop that uses I. Remember, when I declared I up here, I did it inside the round brackets, so the only place I can use I is here. So if I want a second loop that also has a loop variable I, I'm going to redeclare I. Right? This time, our range starts at n true. So I'm going to start I at n true. Right? It runs as long as I is less than the length of the array. So I is less than, okay, how do I get the length of the array? Well, it's ar.length, right, I++. Right. Inside the body of the loop, it's just array I equals false, lowercase f in Java. Right. If you try uppercase f, it's not going to work, it'll complain. Right. So you hover over that, it says false cannot be resolved to a variable. Right. It gives you some options to fix it, none of them are correct in this case, right? The correct thing to do is to make it a little f false. And voila, there's your second method translated right there. Right. Okay, now that I've shown you that, the rest of the assignment should be easy. It's pretty straightforward, right? Translate one line of Python to one line of Java in most cases. All right. Sorry, do you want to take a picture of that? I don't know why you want to take a picture of that. You should be able to do this pretty easily. Oh, sorry, let me get rid of that. Right. This is, I mean, more or less the expectation is that you can do this automatically in a couple of weeks. Yes, question?
Can you explain the throw and the do mean again?
Sure. Okay, I guess what I should do is ask you, have you ever seen this in Python? Okay, great. All right, so in 121, they should have told you how to do some error handling. All right, so in languages like Java and Python, when you write a function in Java, when you write a method, often function or method cannot run if it's given incorrect inputs, right? It's unsensible to run the function or method with incorrect inputs, right? Here, the percent density is the fraction of values that should be true, right? Therefore, this method only, this function only makes sense, or can only run, or can run sensibly, only if the percent density is actually a percentage, right? If it's negative, it doesn't make sense. How does it set a negative number of elements to true, right? If it's greater than 1, it also doesn't make sense. How can it set more elements than there are in the list to true, right? So none of those cases make sense. So you want to indicate to whoever called the function that they've called it incorrectly, right? They've called it with values that are incorrect, right? And so many functions in Python and Java will check their arguments before they actually try to do anything, right? So here, our Python function is checking, is this value less than 0 or greater than 1, right? So if it's less than 0, this is an error. We should tell the caller that they've called the function incorrectly, right? So in other words, the function should not run, right? It shouldn't finish running because it can't do anything with this negative percent density, right? And so what you want to do is you want to stop the function from running, tell the caller they've called the function incorrectly, right? And if the caller is able to respond to this indication that they've called it incorrectly, the caller ought to be able to do, the caller's code should be able to continue running, right? So that last part's a bit abstract at this point in time, right? So for now, let's just focus on the fact that I'm trying to tell the caller they've called the function incorrectly, right? And so the mechanism that you use to do that in Python is you raise an error, right? And so this keyword is raise, right? You choose some kind of error object. So Python lets you choose from, I don't know how many error objects. One of them is called value error, right? There's other ones as well, right? So you raise a value error, and then you can provide, oops, sorry. And then you can provide a message in the error indicating what has gone wrong, right? So when you raise an error in Python, the function immediately stops running at this point, right? So it stops running here. Whoever called the function ends up receiving an object of type value error that has the message that the density is less than 0, right? If the caller doesn't do anything with this object, whoever called the caller now gets the object, now gets the value error object. If they don't do anything with it, the caller of the caller of the caller gets the value error. Eventually, you get back to where the program started, and if it doesn't do anything with the value error object, the program stops running, right? And so you'll get this message that says density less than 0, and your program stops, right? Java is using the exact same thing happens in Java, right? The whole sequence of events is exactly the same. It's just that Java calls errors exceptions, right? And instead of raising them, you throw them, right? And so here you throw in a legal argument exception object. The other difference here is that in Python, so this looks like a function call to most of you, I think, right? The confusing thing in Python is this is not actually a function call, right? What's happening here is that you're calling what's called a constructor to make a value error object, and then you're raising that object, right? And so function calls and constructor calls look the same in Python. In Java, they're different, right? And so if you ever see the word new, right, that's an indication to you that the next thing after it is actually a constructor call. And so here in Java, you're making a new illegal argument exception object, right? So if this happens, method stops running, whoever called the method ends up with this illegal argument exception object that has this message inside of it. The percent density is less than 0, right? So that's what's going on there. I will have to speak to your 121 profs and tell them they should be raising raising errors in their course. This sort of suggests to me that you didn't do any error checking in your Python course, which is not good. All right, so question, yes?
What's the difference between the regular loop that you just showed us?
Right, so Java has two types of for loops, right? Python only has one, right? In Python, all loops are for each loops, right? So Java also has a for each loop. So in Java, if you have an array or some sequence of values, you can write a for each loop on that thing, right? So in Java, you can write a for each loop on an array, right? And the for each loop in Java looks a lot like the Python for each loop, right? So in Python, you would write for boo in ARR, right? In Java, you can write for Boolean boo colon ARR. So that's the equivalent for each loop, right? Each time through the loop, right? Each time through the loop, you'll look at one element in this array, right? You'll start at the first element, then you go to the next element, then the third, and then the fourth, and so on, right? Each time you do that, you can use the name boo to get the value that's stored in the array, right? So first time through the loop, boo is the first element of ARR, right? Second time through the loop, boo is the second element of ARR, right? Third time through, boo is the third, yeah. So that's the for each loop in Java. Java also has the older style counting loop like this, right? And it turns out that in Java, you have to use the counting style loop in some cases. And I'm going to show you exactly when you have to next, right? Okay, any other questions? Super, all right. Okay, so here is an example where, oh wait, let me do one more thing. Loops, okay. So here's max index. Okay, so here's max index. Max index is using a counting style loop. It turns out that in this case, it's possible to rewrite this method so that it uses a for each loop instead. So let's do that. Right. So public static int max index 2. I'll explain why I have to write 2 here in just a second. Okay, so the rule in Java is if you're inside of a class, all of the methods in the class need to have what's called a unique signature. I'll explain in great gory detail exactly what a signature is in a lecture or two. So for the time being though, here, the signature is basically this part of the method, right? So here I've got a method that it's called max index. Its one parameter is an array of double. Right? If I want to put it in another method in the class, right, the signature has to be different than the signatures of all the other methods. Right? So what I cannot do is I can't put in max index double array a second time. Right? When you do that, notice Eclipse flags both of these as being an error. It says you have a duplicate method. Right? So I have to change something. I either have to change the name of the method or I have to change the parameter type. I don't want to change the parameter type, so I have to change the method name here. All right, so let me rewrite this this time using a for each loop. So everything's the same up to this point here. Okay, now instead of using a counting style loop, let's try to do this with with a for each loop. Now remember, with a for each loop, it looks at each element of the array. Right? So I don't have an index here. Instead, what I have is an element of the array. So it's going to look something like this. So for each element in the array, right, I want to check, is that element bigger than the current highest value that I've seen so far? So if elem is greater than high. Okay, now I want to do something, right? And now the question is what do I want to do, right? So what do I do? So I need to assign the index now, right? Well, I need to do two things. I need to remember that the new highest element is equal to a lem. So I can still do that. So how do I set index here, right? So the problem here is that your loop variable is not counting the index anymore, right? It's counting something else. It's not counting at all. It's just looping over elements in the array. If I can set the index, though, I can return the index here. right? So now the problem is, how do I set the index? And the answer is well, you can't really. What you have to do here is you have to keep track of the index yourself. So you need to introduce another variable. Oh, sorry, not index. Int I is equal to 0, right? So each time through the loop, right, if the element is greater than or equal to high, right, then my highest value is now equal to the element, right? I can set index equal to I, right? And you have to do something else, right? Now, every time through the loop, you have to remember, well, what is the current loop iteration? So I have to increment I myself now, right? So you could do this, and this is also correct, right? So here I'm manually keeping track of which element, what is the index of the element I'm looking at every time, right? So if you forget to do this, you're never going to, you will most of the time not return the correct index, right? And it's very easy to forget, right? So if you're in the situation where you actually want to keep track of an index, you're probably better off using the counting style loop in Java. Right. All right. Next example. Okay, so there's another problem with the for each loop, right? So with a for, there's many cases where when you're writing the loop, you need to access more than one element of the array at the same, in the same loop iteration, right? So in the examples we've seen so far, we've only been looking at the current element that the loop is at in the iteration, right? In the case of in the case of solving the problem, is this array sorted? What you want to do is you want to look at two values in the array at the same time, right? The for each loop only lets you look at one. So this is another situation where you probably want to use a regular for loop. You can write a for each loop, it just becomes more awkward to do it, right? So if I want to look at two elements at the same time, it's probably better to just use an index, right? So to check if a list is sorted, what you want to do is you want to look at the first and second elements, right? So if I'm sorting in ascending order, I want to look at the first and second element. If the second element is smaller than the first element, I know it's not sorted, right? If the first element, if the first two elements are sorted, then I want to look at the second and the third element and check if they're in sorted order, right? And then the third and the fourth, first, second, second, third, third, fourth, fifth, and so on, and so on, and so on, right? So here you want to look at every pair of adjacent elements, right? So in other words, what you want to do is this, right? I want to look at the first and second elements. These are sorted, so the loop can continue, right? I now want to look at in the next iteration, I want to look at the second and third elements, right? These are sorted, so the list can continue, right? I want to compare the third and the fourth, right? Eventually you get down to here, right? So I'm comparing the third last and second last, right? Then the second last and the last element, and everything is in sorted order. So here I can finally return true, right? So how do you write that out in code? Okay, so you begin by assuming the list is sorted, the array is sorted, right? So is it sorted? Yes, right? We're just going to assume that the answer is yes. Right? I now want to look at every pair of elements, right? And so there's a bunch of different ways you can write this loop, right? Here, I'm going to start by by making my loop variable I, right? And I'm going to set it to 1 instead of 0, right? As long as I is less than the length of the array, so remember I is my index, right? I want to look at all the elements in the array, right? So as long as I is less than the length of the array, the loop should run. Right? Each time through the loop, I want to increase I by 1. Right? Now, I want to look at the element at index I, and I want to compare that to the element in front of it. Right? So the element in front of it is just the element at index I minus 1. Right? So here, right, I can access a second element of the array because I have an index I, right? And I can do arithmetic with that index. Right? So is the previous element greater than the next element? right? If that's the case, it's not sorted in ascending order. It might be in descending order, but I'm checking for ascending order, right? So if I ever run into the situation, I know the list, the array is not sorted, and I can set is sorted to false, right? I now keep on going, so we process every pair of elements, right? And eventually you're going to either return true or false, right? Notice the way this loop works, right, is it's trying to falsify the assumption here, right? So assume that it's true, right? When you find a situation where it's not sorted, set is sorted to false, right? Whatever you do, don't stick in an else statement here and say is sorted is true, right? You're not keeping track of whether you're not, because that's going to flip back and forth. It's going to flip is sorted back to flip it back and forth between true and false repeatedly, right? If the last two elements have order, right, your method will end up returning true instead of returning the correct answer of false, right? So here I'm trying to find a situation where the list is not sorted, and as soon as the list is not sorted, you never want to set is sorted back to true. Right? So whatever you do here, don't put in the else statement. The logic in your loop is incorrect. Right? And so there's is sorted. Now, you might ask yourself, look, if you look at, if the first two elements are not sorted, right, you know that the rest of the list is not, the rest of the array is not sorted, so you can stop, right? It's not sorted, so you can stop. So if you want to stop a loop, the way you do that is with the break statement. And so the break statement, hopefully they showed you this in 121, right? Python also has a break statement. It will break out of a loop, right? So what break does is it jumps outside of the loop that it's in, right? So if we find a situation where the list is not sorted, break immediately jumps out of the loop and goes to the end of goes to the point immediately after the loop, right? So here we can stop checking elements as soon as we know the array is not sorted. Right? Put it in a break statement, and away you go. Right? So putting in the break statement here saves you some work. Right? Instead of looking at all of the elements in the array, right? Look at enough elements in the array until you know the answer, and then you can stop. Right? That's what the break statement does there. They did show you break in 121, right? Okay, good. All right. With this particular array, right? When we find an element 15 that is smaller than the element in front of it, right? Or equivalently, when we find an element 99 that is bigger than the element after it, we know that the array is not sorted, so you can stop and return false. Okay, here's another example. The loop must access or wants to access more than one element of the array in the same iteration. Right? So to reverse the elements if you have an array or a list and you want to reverse the elements, right? The idea is you want to start with the first element and the last element of the array and switch them, right? So you want to swap their positions. Right? You then want to take the second element and the second last element of the array and swap their positions, right? And so on and so on and so on until you've swapped all of the elements in the array, right? So I know the first element in the array is that has index 0. So I is going to keep track of the element in the front half of the array, right? I need to also keep track of what element am I swapping with at the end of the array, right? And so that's going to be j, right? And notice here, I'm declaring j before the loop, right? So for the first, what is the location of the last element in the array? Well, that's the length of the array A, so that's a.length minus 1, right? So that's the index at the back of the array. In the loop, right, I want to swap the elements at AI, I want to swap the elements AI and AJ. Stuff in 121, right? Yes? Okay, so remember, if you're going to swap two values in most programming languages, you need to introduce a temporary variable, right? So you have to remember the value of one of the two values that you're swapping, right? And then you can switch the values using the temporary value to help you. So I'm going to remember the value at AI, so I'm going to remember the value at the front half of the array, right? Once I've remembered the value at the front part of the array, I can update that value, right? So I can take AI and I can set it to AJ, right? So assign AJ to AI, right? So in other words, copy the element at the back to the element at the front, right? Now, you've overwritten the element at the front. This is why you needed the temporary variable, right? That's why you needed to remember what the old value of the variable was, right? So to move the, or to swap the first element of the array to the last, right? You now reassign the last element of the array to your temporary variable, right? So that swaps the first and last positions of the elements of the array, right? Now, the loop, the counting loop is going to keep track of the index I, right? So each time through the loop, I is going to go up by 1, right? We're keeping track of the ending index ourselves, so that means we have to update the ending index ourselves here, right? So there's that j minus minus there, which is a very, the very easy mistake to make is to forget to increment j, or decrement j in this case, right? So here you have to be careful. You have to remember, oh, I have to adjust this value j as well, right? Because I want to, on the next iteration, I want to swap the second and second last, right? And then the third and the third last, and so on and so on and so forth, right? The other thing you have to pay attention to here is when does this loop stop, right? Notice the termination condition here is not I is less than the length of the array, right? Remember, I is the index in the front half of the list, and j is an index in the back half of the list, right? As soon as I and j cross, right? So as soon as j becomes an index in the front half and I becomes an index in the back half, right? You want to stop, right? If you don't stop, you switch the first and the last, and the second last, and then when you get to the middle, you're going to switch all your elements again. So what you end up doing is putting the list back, the array back into its original order, right? So here the loop termination condition is when, as long as I is less than j, right, the loop should run. So this is a picture of what's happening, right? First time through the loop, right, I'm going to swap these two elements, so the 12 and the 27. Right? Second time through the loop, I'm going to swap the 13 and the 26. Right? Third, and so on and so on and so forth. Right? Now, at some point, I is going to be 7 and j is going to be 8, so I'm going to switch the 19 and the 20. Right? As soon as I do that, I'm done. Right? If you keep on going, I is going to be here. Sorry, I will be here and j will be here. Right? So if I switch these two, it's 2019. If I keep on going, I'm going to switch them again, and you're going to end up with 1920 again. And then the 21 and the 18 will swap, and then the 22 and the 17 will swap, and you will have unreversed your list. Right? So you need to stop here. Right? And so now the loop stops, because I and j are going to cross one another, and you don't want to re-reverse the list. Right? Okay. And so in this example here, right, there's really two loop variables, right? There's I and there's j, right? And so in Java, you can write a loop using more than one loop variable, right? So here, instead of declaring j outside the loop, I can declare j when I declare I, right? So int I is equal to 0, right, comma, right? J is equal to the length of the array minus 1. Right? Similarly, in the update expression, you can update more than one thing if you want. Right? So I can increase I by 1, and I can decrease j by 1. So j minus minus is like I plus plus, except it subtracts 1 from j. Right? J minus equals 1, plus plus j, they will all do something similar. So you can also write the loop like this, right? And that saves you from having to remember to update j yourself down here, right? Which is nice. You have to be careful when you do this. So to do this, there are some restrictions on what you can do, right? So you're only allowed to do this if I and j have the same type, right? So here this works because I and j are both int. There's no way to declare two loop variables that have a different type in Java. All right, so we're out of time. I guess I'll finish up the lecture on Monday, I guess.